Connection interface basics. Vocabulary is always the start of our learning, isn't it? So to that point, let's define what a physical interface is. A physical interface is an electrical circuit that links one device, specifically, let's say a personal computer, desktop or laptop, it doesn't matter, with another device. And this connection requires some kind of connector. Now that connector could take the form of a cable, or we have various wireless technologies like Bluetooth, infrared, and wireless that we'll look at the tail end of this module. But again, just the idea of the interface is that we're extending our computer's functionality. For instance, we may want to plug an external hard drive to our personal computer to give ourselves more storage space. By contrast, we may want to do a USB connection to an inkjet or laser printer such that we can print out photos, documents, and the like. I think you have the general idea. Let's proceed. More vocabulary for you. These are commonly confused terms, and quite honestly, if you fill a room with PC repair technicians, you're liable to see vociferous arguments on either end of the debate. For our purposes, consider a plug and a connector to be the same thing, and this refers to the part of the cable that plugs into a port. You see it right, a serial ATA cable that has plugs or connectors on the end. Male and female is not considered to be so politically correct, but I'm going to use it because I've been in the industry for quite a long time, and I think it makes the most sense. A male connector would be what you have at the end of this cable. The male end of the connector fits into a matching female recessed port or jack that exists, for instance, poking out of the back or front of your computer case, the system motherboard, or an external device like a hard drive or a printer. Jack sometimes is specifically used to denote audio connections that you find on your computer, but port and jack both mean the same thing. In this slide, I'd like to give you 6 connection interface considerations, just some general principles regarding computer connection interfaces. 1, does the cable or the interface carry analog signals, digital signals, or both? We'll get into the specifics of that as we proceed, but that's just something to keep in mind. Analog, remember, refers to a signal path of various intermediate values, like my voice that you're hearing is an analog stream. Digital, of course, refers to zeros and ones, an on-off binary state, and that's ultimately how all computers process data in the first place. We need to keep in mind the distance limitations that are implicit with particular technologies, both for wired, like USB and eSATA, and wireless, like Bluetooth and Wi-Fi. For instance, you may need to put a Wi-Fi extender in an office if you find that the main Wi-Fi access point isn't giving adequate range to everyone in the office. The same goes for physical cables, especially once we start talking about Ethernet networking. That cable distance becomes quite important indeed. Similarly, when we talk about data, both wired and wireless, we want the connection to be as fast as possible. Cable quality gets a lot of press, especially in the entertainment industry. And I don't mean acting, I mean entertainment devices like HD TVs and the notion of building an entertainment center. There's the thought, should I buy a generic HDMI cable or a name brand one? There is some truth that cables are of various quality, but it's not necessarily, in my experience, broken down across name brand lines. You just want to take a look at, was this particular cable handcrafted by an individual and therefore perhaps maybe prone to faults if it hasn't been tested? Or has it been produced by a manufacturer that you have some faith that some QA went into that cable construction? DRM stands for Digital Rights Management. The HDMI cable that's used to carry video and audio signals, both for computer monitors as well as HD TVs, actually has DRM capability built into it. Rights management refers to protecting data streams such that only authorized users can make use of them. Similarly, along all of the previous 5 points lines, interfaces, wired and wireless, operate at particular frequencies or frequency ranges. We're going to be doing a lot with all of these interface considerations in the next course in this learning path, which is all about networking. But for now, we're considered mainly with interfaces from a more general purpose standpoint.